Hello, I wanted to do a quick example walkthrough of how you can create a new class that implements the comparable interface and which uses the factory design pattern. So my example is going to be a cylinder class. I'm going to create a new class called cylinder. And I'm going to go ahead and create a cylinder tester. So in my cylinder class, I'm going to start with the fields. Remember, your fields should be private unless you have a very compelling reason to make them public. So the facts that describe my cylinder are a radius and a height. Now I'll make the constructor. So I'll make one constructor that takes a radius and a height. And I'll go ahead and make getter and setter methods. Okay, so far so good. So now I'm going to make a factory method. So it's going to be static because, well, let me show you how you would use the factory method first. So here we are inside the cylinder tester. Using the constructor, I could create a new cylinder by saying new cylinder and giving it a height and a radius. What I want to be able to do with my factory method is something like this. I want to be able to create an array list of cylinder objects. Why can't I type cylinder? Okay. And I want to be able to have the cylinder class itself return random cylinder instances to me. So I want it to create as many instances as I want it to. So here I'm going to loop 100 times, and I'm going to add to my list the cylinder class create random cylinder. And let's say I can give it a maximum height and a maximum radius. So I haven't made this method yet, but this is the factory method. So it runs not from an instance of cylinder, but from the cylinder class, and its job is to create a new instance and then return it to me. So here we are back in the cylinder class. So I'll make it a static method. I know it needs to return a cylinder object. And what did I call it? Create random cylinder. And it takes two parameters. The first parameter is max radius. The second parameter is max height. One way of thinking about static methods while you're writing them is it's kind of a free-floating method because it's run from the class itself. So that means, for example, I can't use radius. I couldn't say radius equals 5 because radius is a field of a particular cylinder instance. And remember, inside a public method, there is no cylinder instance. It's running from the class. So a good way of thinking about this is it's kind of analogous to a main method or a tester method or a client method that you would write. Like think about this as existing independently of the other things in cylinder. So if I was in a main method and I was just trying to create a cylinder object, I would say cylinder C equals new cylinder. And I would have to give it numbers here. And I could do that, and that makes sense for this static method. But of course, I want it to be a random cylinder, and the values that I generate at random have to be more than 0 and less than these things. So let's do that. So I'll make my radius be math.random times max radius, and my height is going to be math.random times max height. And then that's what I'm going to use to construct my cylinder, and then at the very end I can return my cylinder. So, factory method complete. Now I'll construct random cylinder instances. And then you'll notice back here in the tester, this seems to be working out just fine. So, if I want to be able to print my cylinder, I can't just print it out like this. Well, I mean, I could, but here's what it would look like. It prints the memory address where the object is. So instead of that, I want to create my own string, toString method. So public string, toString. And I think I'll have it display maybe the size and the volume of my cylinder. So I'll return a string that says radius equals radius and height is height, and then volume is get volume, which is a method I haven't written yet. So let's write a get volume method. So my get volume method, I'll return, let's see, it's pi r squared times h. So math.pi times radius, so that's pi r squared times the height. And there we go. Now I've got a get volume. So now back in cylinder tester, when I run it, I got radius 10, height 0, volume 0. Why is my height 0? So something is clearly not working. Let's look at the constructor. Ah, that was weird. So this is backwards. Why would I have done that? That is so bizarre. Okay, well, good thing we tested it. Cool, so radius 10, height 20, there's volume. Cool. So now, last thing, let us implement the comparable interface. So I said the comparable interface lets you compare different cylinder objects. So we'll say implements comparable, and then inside the triangle brackets here we say what is it that we are going to compare cylinder objects to, and I want to compare cylinder objects to other cylinder objects. So it's underlining in red here because when I type implements comparable, I'm making a promise, and the promise is that I will create a compareTo method. So here I've said I'm going to create a compareTo method, but I haven't actually done it yet, and that's why we have a compile time error here. So the compile time error will go away as soon as I create the right kind of compareTo method. So public int compareTo, and then I'm comparing my cylinder to another cylinder. So the input has to be a cylinder, which I will call other. Because the idea is there's going to be a particular cylinder instance that's running this method, and it's going to compare itself to a different cylinder that's the input. So you'll notice the compile time error up here has gone away because now I have fulfilled my promise of implementing a compareTo method. Down inside compareTo, remember if the executing object, if the one that is running compareTo is larger than the other one, we'll return a positive number. If the other one is larger than us, we will return a negative number. If they're the same, we'll return 0. So let's say that we will compare them on the basis of radii. So if a cylinder has a larger radius, that means it will count as being bigger. So we'll just compare the radii. I'll say if this, which is myself, if this executing object, if its radius is larger than the other's radius, then I'll return a positive number, because I am bigger than the other one. If the reverse is true, so if my radius is smaller than the other one's radius, they must be bigger, so I'll return a negative number. Otherwise, they must be the same, so I'll return 0. So now I've got a compareTo method, and if I wanted to here, I could sort all of the cylinders in my list using collections.sort. And then I could print out all of the cylinders, and we could see that the sort has actually worked. So let's use a for each loop here. Cylinder C, list. So every item in list is going to get assigned to that variable. And now I'll system.out.println C. And now when I run it, you'll see we've got large radii, and then as we're going up, we've got smaller radii. So it's sorting on the basis of the radius. Okay, let's change it real quick so that we are sorting by volume, and just notice that that actually makes a change. So here, instead of get radius, let's say get volume everywhere. So if my volume is bigger than their volume, theirs is bigger than mine, and so on. So now, when I run sort over here, when collections sorts my list, sort is going to use this compareTo in order to figure out which one in the list is bigger. And my new compareTo is sorting by volume. So when I run it again, now you see that the radii, are they still sorted? No, so the radii are definitely not in sorted order, because here I've got 472, 423, and then 390, and then back up to 478. So these aren't sorted. But if you look at volume, volume does seem to be sorted. So volume is going E7, this is 7.36 times 10 to the 7th, so these are very large numbers. This is 2.34 times 10 to the 8th, so even though this 2 is smaller, it's actually a larger number because it is times 10 to the 8th. If we go to the top of the list here, you see that it's definitely in sorted order. Okay, that's it.